Mm-hmm.
Let's just talk about this for a second, because this particular problem illustrates something very important. So if these two angles are supplementary, what equation can I write?
Parentheses, negative 4x plus 40 plus parentheses x plus 50 equals 180.
Now, I'm glad you used the parentheses, but they're not actually necessary. The only reason I use them in this problem is for clarification. In other words, this is angle A, that's angle B, you add them the two together. But the fact of the matter is, as long as this is a plus sign right here, then you almost never need the first set of parentheses. I can remove those immediately. And as long as it's a plus sign here, you don't need the second set. Okay? So now, gather variables. What do you have?
Negative 3x plus 90. 180. So x would equal negative 30.
What's x equal?
Negative 30.
Can x be negative?
No.
What's that?
No. Or
Yes, it can. And that's the only reason I wanted to talk about this problem. Angles cannot be negative. But notice that if I plug in negative 30 for angle B, I get minus 4 times negative 30 plus 40. Well, this becomes plus 120, so that's actually equal to 160. And then if I plug in minus 30 for the second angle, I get angle B equals 20. So I get positive angles even with a negative x. And that's fine. You can't have negative angles. In other words, if this x gave us a result that gave me a negative angle, then there would be a problem. But x itself can be negative. It's just the angles cannot.
okay.
At least not until you get to trig. In other words, once you get to trig, they actually do have a way of measuring angles. If you are talking about that angle there, theta, that's measured counterclockwise, and that is a positive angle. If you're talking about that angle, alpha, that's measured clockwise, and that actually is a negative angle. In other words, I might say that's minus 45 degrees. Okay? So it's not really that you can't have negative angles. They do deal with negative angles in trig, but in geometry you can't have negative angles. In your geometry class this whole year, you're not going to ever have negative angles. Okay? It's kind of like dimensions. If you're calculating the dimensions of a triangle and you come up with a negative number for one of the sides, you got real problems. There's no such thing as a negative dimension. You can't have a distance of minus 3 feet.
Mm-hmm.
Okay? Same principle for angles until you get to trig. Okay? Now, I assume that you're in the same geometry class as my other students. Do these look familiar?
Mm-hmm.
So you're in exactly the same class?
I don't know if it's exactly the same class.
But it's the same material.
Yeah.
Okay. I have your book. You have the textbook, right?
Mm-hmm.
Yeah, it's written by Larson, Boswell, and Stiff. I may not have the exact edition that you have, but it's good enough that if you encounter a problem in geometry and some of your homework is from the exercises of the book, you don't need to worry about taking a picture and sending it to me like my other students did. Although I think this material, I was told, was not from the book. This is what the teacher handed out.
Mm-hmm.
In that situation, you would need to send me a picture of it. But if it's, say, exercises from chapter 1 at the back of the book, then just tell me, yeah, it's on page so-and-so. We're going over exercises 10 through 18. And then you don't need to send me anything. Okay? Now, the first chapter, you said you were doing real well on it, and I'm not surprised. It's not very tough. It's pretty straightforward. Chapter 2 is probably going to cause you a little more difficulty. Have you begun chapter 2 yet?
Yeah, we just started it today.
Reasoning and proof. This might be the hardest chapter to tutor of any in math that I've come across. I'm not sure why. Maybe it's just me. Let's talk about the conditional statement, if P, then Q. Is that what you started off with today?
Yeah. No, we didn't start with this, no.
Well, this is generally where logic starts. In other words, chapter 2 is about, it's really logic. It's called reasoning and proofs, but it's really about logic. If I make a conditional statement that says, if P then Q, it's important to understand what that means. It does not mean if Q then P. If the example I always give everybody is, if you live in Colorado, that's the P, then you live in the United States. That's the Q.
So it's like all squares are rectangles, but not all rectangles.
Kind of. There are some if-then statements where you can reverse it. And we'll get to that in a second. But in general, if you're given this logic statement, and when I took logic at Mines, this was the very first day, they talked about if P then Q, you can tell immediately that the reverse is not always true. In other words, if I said if Q then P, that would mean that if you live in the United States, then you live in Colorado, which is not a true statement. You might live in Florida. Okay? So if I say if P then Q does not mean if Q then P. But what it does mean always, every time, is if not Q, the second part, then not P. Notice in my example, I can say that if you do not live in the United States, then it's true that you do not live in Colorado. So these always go together. If P then Q means also if not Q then not P. Now, there are some statements that are if and only if. If I said if and only if x squared equals 16, then x equals plus or minus 4. Now, this is an if and only if P, then Q. If you have if and only if P, then Q, then it's also true that if you have Q, then P is true. In other words, this is certainly true. If x squared equals 16, then x is equal to plus or minus 4. But it's also true that if x is equal to plus or minus 4, then x squared equals 16. So sometimes you have if and only if statements. And in fact, there's all kinds of degrees of conditionality. These are all called conditional statements. And you're going to learn terms like the inverse, the converse, and the contrapositive. And in fact, did you talk about those today?
No.
Let's go over them because you'll be better off, you'll be better prepared for them if you have some familiarity with. So let's just go over these. I think this is the best thing for you. I've never met anybody that doesn't have problems with proofs. It's the hardest part of geometry, and yet they give it to you in chapter 2, which tends to demoralize everybody. I've always felt like they should not teach reasoning and proofs until the end of geometry. Let everybody go through the easy part first. And that's why all summer we didn't even deal with this. We dealt with angles, lines, circles, quadrilaterals, stuff like that. Okay? Now, this statement here, if the measurement of angle A is 30 degrees, then the angle A is acute. Okay? If that's the original, let's talk about the inverse. The inverse would be if the measurement of angle A is not 30 degrees, then angle A is not acute. Notice that is all I do is take my original statement and put not in front of both parts. Is this inverse true?
Yes.
No, not really. What if angle A is 40 degrees? Then it would not be 30 degrees, but it would still be acute. So the inverse, if the original is if P then Q, then the inverse is if not P, then not Q. And in this case, the inverse is not true. Not true. Okay? But it's still called the inverse. In other words, when you go to memorize these, just think of the inverse as being the original. This is if P then Q. And it's just if not P then not Q. And it's rare that the inverse is true. Usually it's not true. Let's talk about the converse. If you didn't learn these terms today, you'll learn them tomorrow. And the converse would be if angle A is acute, then angle A equals 30 degrees. In other words, this has the form if Q, then P. Is that true for this one?
Not necessarily.
No, not true also. And when you say not necessarily, you can just say not true. Okay? Some of these are going to be always true. Some of them are going to be not true. And the not true ones are sometimes true. In other words, the converse could be true. If the measurement of A is acute, then it could be 30 degrees, but it doesn't have to be. It could be 40 degrees or 48 degrees or 89 degrees. And there's one more, and that's called the contrapositive. And you need to memorize that, and that. And what the contrapositive says is if angle A is not acute, then angle A is not 30 degrees. Is that true?
Yes.
And that is if not Q, then not P. And the contrapositive is always true. Okay? In other words, if you say if P then Q, then it's always true that if not Q, then not P. And it's called the contrapositive. The inverse is sometimes true. The converse is sometimes true. The contrapositive is always true. Okay? Now, let me just look through here. All right, let's do some practice. I'm going to give you a conditional statement, and I want you to give me each of those. If there is snow on the ground, then flowers are not in bloom. Okay, so that's the original. Now let's go back and take a look at the inverse. The inverse is if not P, then not Q. So what would the inverse of this be?
If there are not flowers on the ground, if there's not snow on the ground, then flowers are not in bloom.
Is that a true statement?
No.
True, because in the middle of December you can have no snow, but there aren't going to be flowers. Well, hold on a second. Let me restate that. If there is not snow, then flowers are not in bloom. Well, that's not true. In the middle of this, I gave you a bad example. In the middle of June, there's not going to be snow, but there are going to be flowers in bloom. So the inverse is not always true. The next one is the converse. And the converse is if Q, then P. In other words, the converse just reverses the two things.
So if they're...
Hold on a moment. I may have done the inverse wrong. I did do the inverse wrong. The inverse is the negative of P and the negative of Q.
So if there's no snow on the ground, then flowers are in bloom.
Yes.
Okay.
And maybe I was thinking that, and I wrote the other, because that is December. In other words, there can be no snow on the ground, but flowers aren't necessarily in bloom just because there's no snow on the ground. It can still be the middle of winter. Okay? So the inverse is not true.
Mm-hmm.
And this is actually a pretty good example because the Q was a negative. So when you do a negative of a negative, it's like doing minus a minus. Okay, what's the converse? And remember, the converse is just turning the two around. The converse is if Q, then P.
So if there are not flowers on the ground, then there is snow on the ground?
Yeah. If there are not flowers, there is snow. Is that true? Just think about your yard.
Not always.
Yeah, if it's the middle of July, you don't always have flowers, right?
Sometimes during December, you're not going to have snow on the ground.
Well, the key here is if we do not see any flowers, can we assume that there's going to be snow? No. I'm looking at my backyard right now and I don't see any flowers.
Yeah.
But there's no snow. So that's also not true. And now finally, let's end it with the third, which is called the contrapositive, which is where you reverse the two things and you throw in a negative. So what would if the original is that, if there is snow on the ground, then flowers are not in bloom. Start with the flowers being not in bloom, take the negative of that, that's if PQ.
Flowers are on the ground, then there is no snow. So if flowers are in bloom, there's no snow.
And that is true. Assuming, of course. In other words, there certainly are times in real life where you can see flowers and snow on the ground. Okay? Mm-hmm. So the contrapositive is always true, assuming the original is true. Well, what did the original say? The original said, if there is snow on the ground, then flowers are not in bloom. That's actually not always true.
Mm-hmm.
Okay, but if we assume that that is always true, then you can definitely say the contrapositive. If there are flowers are on the ground, then there is no snow. So these three things, the original, the inverse, the converse, and the contrapositive, memorize those.
Mm-hmm.
And you can just memorize them relative to P and Q. Okay? In other words, all of these can be memorized relative to P and Q. And it's just substituting a statement for P and another statement for Q. And that's all it is. And it doesn't really matter what that statement is, and that statement can actually have a negative in it as well. But, all right. I'm glad we covered that. That should help you in tomorrow's class. Do you have math every day this week? Or every week?
Every day.
5 times a week?
Mm-hmm.
Okay. Well, you almost certainly will cover these 3 tomorrow because they are in the beginning of my chapter 2. And unless they've changed the book considerably, you will get all of these, as well as a bunch of things called postulates.
Yeah, we already went over
that. Geometry is full of theorems, postulates, and corollaries. Actually, when I took geometry, they just called them theorems and corollaries. now they have postulates also. And these are just statements kind of truth that at some point needed to be proven, but once they were proven, they're always going to be true. Kind of like the Pythagorean Theorem, you know. If you have a right triangle, then a squared plus b squared equals c squared. That's actually if and only if. In other words, that works both ways. The inverse is true, the converse is true, and the contrapositive is true. If you have a right triangle, what was the Q part? The Pythagorean Theorem is true. In other words, if you have a right triangle, then the Pythagorean Theorem is true. And if the Pythagorean Theorem is true, then you have a right triangle also. So the original, the inverse, the converse, and the contrapositive would all be true for that, which is generally the case if you have an if and only if statement.
Mm-hmm.
All right. I will let you go. And let's see. Do you want to change your regular? Does Monday at 3? Is that still going to be the best for you?
Work.
I'm sorry. What?
That's still probably going to be the best.
Okay. I'll leave it at Monday at 3.
All right.
All right.
Does he want to work on Labor Day?
Yeah.
Well, that's Labor Day. Do you want to work on Labor Day?
I don't care. Sure, I'm fine with it.
Okay.
All right. Sounds good.
Okay. I'll talk to you Monday at 3.
Talk to you Monday at 3.
All right, cool. Bye-bye.